Okay, I'm going to show you how to do an orbital diagram. So I'm going to start with fluorine, and I have fluorine's electron configuration listed out here, just a review of that. It's 1s2, 2s2, 2p5, and that's because fluorine is in the second energy level in the p block, and it's the fifth element up there. And you double check that you did it right when you add up all the little numbers, the superscripts, and 5 plus 2 plus 2 makes 9. That's fluorine's atomic number. So we have 9 electrons. Now we're going to do what's called an orbital diagram. An orbital diagram is a visual way to show where those electrons are. So you draw a little dash, and for the s orbitals you draw one dash. And then there are 2 electrons in the 1s orbital, so you draw one arrow going up and one arrow going down. And those represent electrons going in opposite spin. And then you draw the 2s orbital, and you draw one electron going up and one going down. Once again, they're going in opposite spin, and there's 2 electrons in the s orbital filling it all up. And then we have the 2p orbital. The 2p orbital has 3 spots available in because you can hold 6 electrons. So you do one electron up, one electron up, one electron up. Now we're putting in 5, so we've done 3, and now we go down, and then we go down. So you have an empty spot available in the 2p orbital, and that's the way it's supposed to look. That's where another electron would like to join and make a full octet, but it's currently not full. Now I'm going to show you aluminum's orbital diagram. I have the electron configuration for aluminum written out. Now you can write it out the long way, which I have here on the top, or you can do the abbreviation. Either one is fine. The shortcut I think is easier, especially when doing the electron configuration, or the orbital diagram. So let me show you how to do that. I'm going to take this one this time. If you're doing the orbital diagram using the shortcut, you can just write, start with the shortcut, the noble gas notation in brackets, and then 1 dash with 3s. Every time you do an orbital diagram for an s orbital, it's 1 dash, and that one's full, once again, because you get this 2 electrons here. And then we have to draw 3 dashes for a p orbital, because a p orbital could have 6 electrons, but we only have 1 in this situation. And then you're going to have 1 arrow just going up, and the rest are blank. That is how to do the orbital diagram.